Hello, class. Over the past couple of days, we've talked about both additive and proportional relationships. So today we're going to take it a step further and we're going to talk about how to determine if a table, graph, or equation is additive or proportional. So let's first look at additive. We are given this table where we have our input and our output. So we need to then figure out what is happening when x goes in and y comes out. So what operation is done from 1 to 5 in the first row? Well, I know off the top of my head that it could be plus 4, or I could be multiplying by 5. In the next row, we go from 2 to 6. So I know that that again could be plus 4, or it could be times 3. The third row has 4 going in and 8 coming out. So the operation could be plus 4, or it could be times 2. So what rule or operation worked for every single row? We can go back and see that that is plus 4 on every single row. So this represents an additive relationship. It is a relationship between x and y with addition. It can be written as y equals x plus b. The b is our y-intercept, which we use when we go down into our graphs. The y-intercept is where the line crosses the y-axis. So every single time I saw that I was adding 4 whenever x went in, so my equation for this line would be y equals x plus 4. No matter what x is going in, we always have to add 4. Therefore, we know that when we cross our y-axis, we're going to be crossing it at positive 4. 1, 2, 3, 4. From there, we have to make more points, and we're just going to go up 1 over 1 every single time. Make our little staircase, up 1 over 1, up 1 over 1. And once we have a few points on there, we're going to use a straight line to connect all of our points. Our y-intercept for this point is wherever it crosses the y-axis. So this right here is my y-axis, and I'm looking for where it crosses. So I know that it crosses at 0, 4. Therefore, my b is positive 4. When we flip it over to the back, we're given a new table. Once again, we have our inputs and our outputs, so we still have to determine our operation. If I have 1 going in and 4 coming out right here on my first row, I know that it could be plus 3, or it could be times 4. On the next one, I have 2 going in and 5 coming out, so I know it could be plus 3, or it could be times 2.5. Right from there, I can see that my multiplications do not match. In one, I have times 4, in the other, I have times 2.5. So I know that this cannot be a proportional relationship. And I'm going to keep going just to check and make sure my rule works every time. 4 goes in and 7 comes out, which means this is still plus 3. So now that I have my rule, I know that every single time I'm going to be adding 3. I know if 0 goes in and I add 3, the y coming out is going to be positive 3. That means that my y-intercept is already given to me in this table. My y-intercept is whenever x is 0. So my x is 0 and my y is 3. Therefore, just like we did on our last problem, our b or our y-intercept is going to be 3. And I can use all of this information because I remember that y equals x plus b. So if b is 3, I can just plug it right into my equation. Y equals x plus 3. Looking down at our next problem, we're still going to think through what operation is happening each time. If 4 goes in and 2 comes out, I know that I could be subtracting 2, or I could be dividing by 2. 5 goes in and 3 comes out, I could be subtracting 2, or I could be dividing by 1.66 and some numbers, repeating. And automatically I see that these do not match. So it can't be a proportional relationship. I have to continue and make sure that this rule, -2 or -2, works every single time. So 7 goes in, 5 comes out. I know that that is -2. And this rule is working every single time. So if I'm using this rule and 0 goes in, I still have to subtract 2. So 0 minus 2 gives me -2. And then that right there tells me my y-intercept, because my y-intercept is whenever x is 0. So 0, -2 is my y-intercept. And from there, I know that -2 is b. Thinking back to y equals x plus b, I can plug that in and figure out that my equation is y equals x minus 2. Our final example is finding our equation and our y-intercept from a graph. So I see that the first thing I want to look for is on my y-axis. Right here, my y-axis is going up and down, and I'm going to figure out where my line crosses. So I see that it crosses right here at this point, and I know that the ordered pair for that point is 0, 2. So my y-intercept is going to be 0, 2. And if I wanted to write an equation from that, I just have to take it the next step. Y equals x plus 2. Now that we've looked back at our additive, we can move over to our proportional or multiplicative. When we're given our table for this, we still have to ask ourselves what operation is being done. Our x goes in, our y comes out, so what's happening in between? If 1 goes in and 3 comes out, I know that it could be plus 2, or it could be times 3. If 2 goes in and 6 comes out, I know that it could be plus 4, or it could be times 3. And already we can start to see a pattern, but we have to continue to make sure it works every time. So I see on the next row 3 goes in and 9 comes out. So I see that I could be adding 6, or I could be multiplying by 3. So then we ask ourselves what rule or operation worked every single time. Every single time I was able to see that I multiplied by 3. So this is a proportional relationship. It's a relationship between x and y with multiplication by a number, m. And it can be written as y equals mx. And whenever I put a number in there, a number next to an x means that I'm going to multiply. So m is our rate of change, or our slope. If we are taking our points that we had from our first problem, or from our first table, and we plug them into our graph down here, I know that the first point is going to be at 1, 3. My next point is going to be at 2, 6. And I would keep going from there, connecting my line and creating a straight line with a ruler or a straight edge. Now that I have my graph, I can go and figure out my slope. So I would have to do rise over run to find my slope on this graph. I'm going to pick 2 points that are easy to read that I could find the coordinates for. And I'm going to create my triangle. I go up and then I go over. My alignment's a little off, but that's all right. So The first thing I want to find is my rise. How far up did I go? I went up 1, 2, 3. So my rise is 3. And my run is how far over I went. So from one point to the next, I went over 1. Now my slope is originally going to be written as a fraction because I put rise over run. So I do 3 over 1, which can be simplified to just 3. On the back, we're given some more examples. So I see I'm given a new table with an input and an output, an X and a Y, and I'm going to figure out what operation works every single time. So 3 goes in and 6 comes out. I know that I could be adding 3 or multiplying by 2. For the next one, for the next row, we have 4 going in and 8 coming out. So I could be doing plus 4, or I could be doing times 2. The next row, 5 goes in and 10 comes out, so I could be doing plus 5 or times 2. So then we have to ask ourselves which operation worked every single time. I can see that I'm adding a different number every time, but multiplication stays the same. So my slope is going to be 2 because every single time I was multiplying by 2. Now my equation is just plugging that in for y equals nx. So y equals 2x is my equation. On the next problem, I'm going to look at the table and try and find my operation again. So for my following table, I see that if my x is going in and my y is coming out, 2 goes in and 10 comes out, I could be adding 8 or multiplying by 5. 4 goes in and 20 comes out, I could be adding 16 or multiplying by 5. Already I can see that the addition doesn't match, but our multiplication does. So I'm going to keep going and make sure it works all the way down. If 7 goes in and 35 comes out, I know that I can still multiply by 5. So my rule works every single time. Now, this table leaves us our blank. So we need to go back and decide if 0 goes in, and I still use my same rule, multiply by 5, what's going to come out? I know that 0 times 5 is 0. So my point is going to be 0, 0. My slope for this graph, if we're trying to write our equation, is going to be 5 because every single time I was multiplying by 5. So my equation, I just get to plug it in for m, y equals 5x. One very interesting thing, or to point out, is that every proportional relationship is going to go through this point, this 0, 0, or the origin. All of our proportional relationships will go through the origin. So down here, I see that my graph is going through 0, 0, and I want to find the slope. So that means I'm going to need to find another point that's easy to read, and I'm going to create my triangle for rise over run. From one point to the next, I had to go up and over. So my rise over run. My rise for this, I went up 1, 2, and my run, I just went over 1. So my slope is going to be 2 over 1, or it could be simplified to just 2. You guys are going to be going on to use these notes to finish up your math space and your IXL.